In this video for JEE and NEET, we will learn about center of mass. When we have a small mass, the particles of the mass have more or less same velocity. So we can represent them with a single velocity, a single displacement and single acceleration. So applying Newton's laws or work energy theorem is easier. But when we deal with a large mass or system of particles, then different particles may have different velocities, and given the large number of particles present in the system, it is almost impossible to study each of them separately. So we needed a method in place to study such large systems. Center of mass is of help to us in such situations. Center of mass represent the entire system with a single point mass, and therefore it will have a single velocity, which we will call as velocity of center of mass, a single acceleration, which we will call acceleration of center of mass, and the displacement of center of mass will represent displacement of all the particles present in the system. So this is the concept with which center of mass came into existence. But how to choose center of mass, and what does a common velocity or a common acceleration or a common displacement mean when we are studying large number of particles, each of which have different velocity, different acceleration, and obviously have different displacements. Center of mass represent translatory motion of system of particles. By translatory motion, we mean that the velocity of center of mass represents the velocity of all the particles present on the system. System is said to be in translatory motion when all the particles of the system has same velocity. Now, how to obtain this common velocity? The central point for choosing a common velocity or the center of mass is the Newton's second law, which says force net acting on a system is equal to rate of change of momentum of the system, and therefore the momentum of the system, which taken individually, will be m1v1, m2v2 and mnvn. So if there is to be a single point mass which can represent this momentum, then its mass, which is sum of mass of all the particles of the system, and velocity, which is the velocity of center of mass, should be equal to the sum of momentum of the particles of the system. So this is how center of mass came into existence, and the velocity of center of mass can be represented. Extending this, the acceleration of center of mass can also be summed as total mass of the system and acceleration of center of mass. And obviously, if velocities and accelerations are represented by this expression, then position of the particles together with their masses will also be represented by m and r center of mass, and hence we have a mathematical form for center of mass. But remember, center of mass represents translatory motion. Center of mass can represent momentum. Center of mass can represent net force equal to mass into acceleration of center of mass. But center of mass do fail in some cases, like representing kinetic energy of the system. If I write it as half total mass of the system and velocity of center of mass square, assuming that center of mass will represent the kinetic energy of the system because it was representing the system anyway, then this is wrong. Center of mass alone cannot represent kinetic energy of the system. But then in this limitation also lies a merit. Although center of mass alone cannot represent kinetic energy of the system, but center of mass help us in writing kinetic energy of the system, and kinetic energy of the system can be written as half m v center of mass square plus half I center of mass and omega square in case of rigid bodies, or in other cases it can be written as half m v center of mass square plus the kinetic energy seen by center of mass. The kinetic energy seen by center of mass is the kinetic energy seen by observer present on the center of mass. So with the help of center of mass we can finally write kinetic energy also. Thank you.